Good morning. Today we are going to see fluids, pressure, particularly in solids and liquids. Okay. So before going to the characteristics or properties, we will see an example. A book is been kept on a table. It exerts some pressure even though when it is at rest. So how to calculate the pressure? It is the force of the body, that is the book weight, which is acting perpendicularly downwards, where it is acting not to the table entirely but only to the bottom part of the book surface, right? So force pressure is equal to weight of the book, that is F, and the bottom surface area of the book on the table is the area there to be calculated. Okay. So some of the characteristics or properties to be remembered in pressure in solids are the pressures are not created or cannot be created in solids on their own because they are closely packed. Okay. And one more thing, solids can exert the pressure even though when they are at rest or even when they are pushed. Okay. And one more thing, animals like polar bears have a very large feet to minimize their pressure on snow. Similarly, camels also having a very large feet walking in sand so that to get a grip there. Okay. So wider area means less pressure, smaller area means more pressure. Okay. Coming back to the liquids, here the pressure calculation does not be forced by area. A little lightly they are changing here because it depends on the gravity as well as their density. Okay. And height. So when you are in a swimming pool, okay, you will experience more pressure when you are going deeper down. Coming to this picture, here the girl in the one at the top experience less pressure compared to this girl because she is slightly deeper down than this one because the molecules are moving here and there, the collisions are more. Okay, it depends on two things. One thing is the gravity of the liquid which is acting above her, and the height or the depth of the object. She is deeper down compared to the other two persons there. So the pressure will be more for her. When a swimmer is deeper down, they can experience the pressure in their ear because of the fluid density and the depth they are in the water. Okay. And the liquids does not depend on the area of the object, size of the object and shape of the object. Okay. So how to calculate the pressure? Rho GH. Rho the density of the water which is above, G is the gravity and H is the height of the object person swimming in the water. Okay. Thank you.